So we've got a truck and a car moving the same direction, rolling, no power, and they collide. And then after the collision, the difference between their velocities is 15 kilometers an hour relative to the truck. It asks, determine the coefficient of restitution between the truck and the car and the loss of energy due to the collision. So we're going to start out by using conservation of momentum to find the velocities, and then we'll use that coefficient of those velocities to find the coefficient of restitution, and then we'll use the energy equations to solve for the loss of energy. So starting with the conservation of momentum, we have mass of the truck, velocity of the truck initially, plus the mass of the car, volume of the car initially, equals the mass of the truck, volume of the velocity of the truck finally, and the mass of the car, velocity of the car at the end. So I'm going to multiply both sides of the equation by g, so I can go ahead and use the, I guess that's megagrams, so it's mass, so I don't have to worry about that. So I'm going to multiply this by 5 and this by 30 plus 2 and 10, and that equals 5, and v of the truck final plus 2, and that's going to be v of the truck final plus 15, because it's going 15 to the right relative to the truck. So solving this, we get 140 equals 7 v of the truck final. Okay, and then 220 equals, and that's kilometers per hour. And then if we add 15 to that, v of the car equals 35 kilometers per hour. And then if we use the E equation, E equals the velocity of the car final minus velocity of the truck final over v of the car initial minus v of the truck initial. So we'll fill that out. We get 35 minus 20 over 30 minus 10. So E is equal to 0.75. Now we'll do energy loss. So first thing we need to do is convert miles per hour to meters per second, because to get the right units. And instead of using 5 and 2, we'll have to use 5,000 and 2,000. So 20 kilometers per hour equals 20,000 divided by 3,600, and that equals 5.56 meters per second, and equally 35 kilometers an hour equals 9.72 meters per second, and 30 kilometers an hour equals 8.33, and 10 kilometers an hour equals 2.78. And with those done, we can do energy before. And we get the energy before is 1/2 mv squared of the truck plus 1/2 mv squared of the car. That equals 1/2 5,000 times 8.33 squared plus 1/2 2,000 2.78 squared. and that equals 181,200. And then the energy after, we got the same, 1/2 of the truck, 1/2 of the car, and then that comes down to 1/2, 5,000, and now we have 5.656 squared plus 1/2, 2,000, 9.72 squared, which is 17,1800. If we subtract those two, we get the energy loss of 9,400 joules.